And one of the reasons why I scheduled today's lesson when I did is that, the 28th will be an anniversary of that. And NASA, last Thursday of the month of January, always does a Day of Remembrance activity. And so I mentioned a feature from last year, but I will also show you that they've already released information about this year's tribute, both Apollo 1, which that was 55 years ago now, and then also Challenger and the Columbia cruise. Apollo 1 was in 1967, and that, Challenger was in 1986, 73 seconds after liftoff. And then, of course, Columbia was coming back in February of 2003. And I know that's not the focus of our event today, but since that is coming up this week, I did want to share that. So let's go ahead and get started. I want to start out with a video that is highlighting a presentation that's talking about the Teacher in Space program. And it talks about the competition, the selection, and, of course, Christa. So here is the link to that in case there are issues with this video. I will tell you the YouTube video is a little, the audio is not as loud as I would like it. I've done some adjustments here.
Communicating the space experience, sending someone into Earth orbit who could tell us what it's like in our own terms, has long been a NASA goal. And in August 1984, the Spaceflight Participant Program was given the green light by President Reagan.
Today I'm directing NASA to begin a search in all of our elementary and secondary schools and to choose as the first citizen passenger in the history of our space program, one of America's finest, a teacher.
Last June, the semi-finalists in NASA's Teacher in Space project met the press for the first time in Washington, D.C. The 114 educators, selected from over 11,000 applicants, spent a week in the nation's capital, becoming familiar with the history of space travel, and of course, taking notes in workshops dealing with various aspects of shuttle flight.
Let's get it red hot.
The next major milestone came in early July, when the 10 finalists were announced. These teachers had survived an extensive screening process, but they had to demonstrate even more right stuff during their 2-week stay at the Johnson Space Center in Houston, Texas. After a series of tests to ensure that they were medically fit to fly aboard the shuttle, the 10 were given a ride on the KC-135, a hollowed-out padded jet that simulates weightlessness for short periods of time. Finally, on July 19th, Vice President Bush made the historic announcement.
Congratulations.
And we have a elementary school teacher from McCall, Idaho, was selected as the backup candidate, and Christa McAuliffe,
Journal of
Harvard New Hampshire High School Social Studies teacher, will be the one to actually fly in space early next year.
It's not often that a teacher is at a loss for words. I know my students wouldn't think so. I've made 9 wonderful friends over the last 2 weeks. And when that shuttle goes, they might be one body. But there's going to be 10 souls that I'm taking with me. Thank you.
You can see everything from test.
Since their selection, your training in Houston. There's been a lot to learn, but they've shown that good teachers make excellent students. During her shuttle flight, in addition to keeping the journal, Mrs. McAuliffe will teach 2 live lessons from space. One called The Ultimate Field Trip, and the other, Where We've Been, Where We're Going, Why, which will be broadcast via satellite to schools around the country. She also has a number of other experiments that will be filmed for classroom use after the mission is complete. Her goal?
I would like to humanize the space age by giving a perspective from a non-astronaut, because I think the students will look at that and say, this is an ordinary person. This ordinary person is contributing to history, and if they can make that connection, then they're going to get excited about history, they're going to get excited about the future, they're going to get excited about space.
While Christa prepares for her flight, life goes on in Concord, New Hampshire, where she has taught for the past 5 years. Understandably, things at the McAuliffe house have changed. For example, there's now a noticeable path from the freezer to the microwave. But husband Stephen, in turn, Daughter Caroline and son Scott have taken on their added responsibilities without reservations.
You know, you're talking about a human being being free of the bounds of gravity, orbiting the Earth. There aren't many human beings that have done that. So I think both of us feel that whatever the price in terms of readjustments or my taking on things that I probably should have been doing before anyway and hadn't done, whatever those prices are, they certainly pale in comparison to the opportunity.
Visit Compton High, and you immediately understand what a special teacher Mrs. McAuliffe is. Former student Andy Clark.
Even though Mrs. McAuliffe was a great economics teacher, I think what I learned most from her was outside the classroom. She taught me that the little person counts and that anyone can make an effect on our society and on the world. She proved that by being the first private citizen in space and being the first teacher in space. And I think she's a tribute to her profession, and we're all very proud of her.
Even amidst the excitement of witnessing she doesn't forget her students.
I mean, the whole thing is so gorgeous. You just want to bring it all back into the classroom for the kids.
Talking about this program, it was called Teacher in Space Project. Now, there is a current Teachers in Space project, but the program that sent Christa McCullough and Barbara Morgan as the backup was known as Teacher in Space Project. And it ran from 1994 to 1990. And the goal was to spur student interest in mathematics, science, and space exploration. They trained for 5 months, where typically an astronaut will train for 2 years. And after flying, they were expected to continue teaching within their classroom. In 1984, President Reagan announced that an elementary or, excuse me, a secondary teacher would be the first citizen passenger to fly in space aboard the space shuttle. There were over 11,000 applicants. It was narrowed down to 114 finalists. There were 2 from each state and territory, as well as Department of Defense and Department of State overseas schools and the Bureau of Indian Affairs, which made up the 114. But they were narrowed down to 10 finalists, and those 10 finalists went to Johnson Space Center for further training. And here you can see President George Bush announcing that Christa McCullough will be the first citizen to fly in space. And this was in Washington, D.C., July of 1985. Ultimately, Christa McCullough was selected as the primary, and Barbara Morgan was the backup. You can see the inset picture of both Christa and Barbara there. McCullough wrote in her application that she wanted to demystify NASA and spaceflight. She wanted to keep a diary to humanize her experiences, and she wanted to see students see and understand the special perspective of space and how it relates to them. And I think that as you work through some of these activities that are part of her lost lessons, you'll see how that truly those lessons were definitely supporting her goals and desires that she had said. This is one of my favorite pictures of Christa. This is in a zero-G training, but Christa was a high school social studies teacher, and her plan was to teach 2 15-minute lessons from on board the space shuttle. We saw part of one there at the beginning, and she was the oldest child, and her father at the time was a sophomore in Boston College whenever she was born, but not too long after that, they grew up in the suburb of Boston. She was extremely excited over the Apollo program. She said she watched the space age being born, and she would love to participate. And through the Teachers in Space program, she was selected for that. She was selected for the position in the summer of '84. And so in that fall, she took a year-long leave of absence, during which time NASA paid her salary and trained her in an early 1986 for the shuttle mission. She had an immediate rapport with the media. The Teacher in Space program received tremendous popular attention because of that. And in part of the excitement over McAuliffe's presence and on the shuttle Challenger, that the accident truly had such a significant impact on the nation, and I'll say definitely on me as well. Prior to flying on the space shuttle, there was zero-G training. On the left, you can see Christa and Barbara playing leapfrog. That was during their zero-G chamber exercises. On the right, Christa and Barbara are actually injecting a hydrophonic solution into a cylinder while in zero-G. This was a practice for one of the activities that Christa had planned on the flight, and had events happen differently, those science lessons would have been brought to around the world. The lessons were prepared, and so were the children, but they were never performed. And the really neat part is that I'll share a little bit later is that we've had some educator astronauts who have carried on the torch for Christa, and Ricky Arnold and Joe Acaba helped to complete Christa's experiments recently on board the International Space Station. I'll get to that in a few minutes, but I want to, give a little bit more history, because in addition to the live lessons that Christa had planned, she had a number of demonstrations during the flight. The filmed activities, which are known as the 6 lost lessons, were to be used as a part of several educational packages that were to be distributed after the mission. In addition to those 6 lost activity lessons, there were those 2 live lessons that were to be televised on PBS, which were set for the 6th day of the mission. In space, I don't want to say that every minute is labeled and planned, but very much so. And so one of the field trips, what they call the ultimate field trip, they had dealt with explaining to students the general layout of the shuttle. And I know at this point it's a little historical, as the shuttle is no longer flying, but I want to go ahead and share that with you. Again, if you have internet issues, you can feel free to go ahead and tap on the link there. It'll take you straight to YouTube, and you don't have to then filter it through Adobe Connect. But here is a take of that field trip as they had planned it while here on Earth.
We have good Teachers TV. Go ahead with the lesson, Christa.
Okay. Good morning. This is Christa McAuliffe, live from the Challenger, and I'm going to be taking you through a field trip. I'm going to start out introducing you to 2 very important members of the crew. The first one is Commander Scobie, who is sitting to my left, and the second one is Michael Smith. Now, Commander Scobie is going to tell you a little bit about flying the orbiter, and Pilot Smith is going to be telling you a little bit about the Spock, which is the computer that is used on board. Okay, after they talk about that, I'm going to be talking about the seats and how people are seated during takeoff. And I'll be pointing to the 2 seats or the positions on the floor. Then I'm going to be going to the aft flight deck and show how it can be flown from the back, pointing to the payload bay windows, the overhead windows, how you can see out, and the mission-specific panels that are going to be behind me. I'm going to be standing right here because Dick's going to be in this seat, and Mike is going to be kind of balanced to his right with the Spock on his lap. He's going to pull the Spock out, and he's going to be over here. Okay, at that point, Mike's going to move out of the way, and I'm going to be going downstairs. Okay?
Okay, ready to come down?
All right, now when I go downstairs, that's going to move.
I'm going to switch the cameras.
Okay, and I'm going to pick up the handheld mic down here. Now, the camera that is right over here should pick me up coming down. We're going to talk about the bathroom first? Is that what we decided? Oh, the handheld mic. Okay. Yeah, I wish I had my... Ron's going to be standing right here. Okay? All right. So... Can I just talk and... Okay. Once I get down to the mid-deck, I'll be talking about the WCS. Can you see the WCS?
Yes.
Okay.
Yes, I can see it.
All right. So the first part, after I push the privacy curtain away, I'm going to be standing over here by the WCS, talking to that camera, explaining how this is configured, talking about the towels and the washcloth. And I'll be talking about the seat. The other person is going to be sitting right in front of the WCS for takeoff and re-entry. And then I'll talk about the sleep bag. Now, at this point, as I'm talking about the sleep bag, hopefully this camera is going to be ready. Okay, and that's why we put the sleep bag in, because we didn't know whether they'd have enough time if all I talked about was the WCS. So we thought I could talk about the sleep restraint and maybe, you know, mention the hatch, but then turn to Ron at the galley, and he would be taking a container out, and I'd be explaining that this is how we rehydrate the food, and he will do the container for me since I have the handheld mic.
He'll do it right.
Okay. Okay, yeah, showing how the drink container works, and then he'll put that back on. Okay? At that point, he's going to... Well, I think we left it open. He's going to open up one of the lockers, and it's just going to be a clothing locker, and it's going to have the restraint here, so I can explain to the kids that everything has to be held down, because otherwise we'd have a problem with things floating away. Okay? Then he's going to put that back in the locker, and while he's putting it back, I'm going to be talking about the treadmill that's going to be here. Now, as I'm talking about the treadmill, this is the cue for the crew to start floating into view.
Think about what it would have been like to have seen that live, but thankful that we have the B-roll footage so that we can still see that. So Christa was set to be a education specialist, and partnership with NASA and STEM on Station, the Challenger Center, which was created in honor of those lost in the Challenger crew, worked with astronauts Ricky Arnold and Joe Acaba to demonstrate those lost lessons during the 2017-2018 school year, so that teachers in the classroom today can replicate what McAuliffe wasn't able to do in space. All 6 scripted experiments have been made available. They include a materials list, set up step-by-step instructions, and I'll be sharing all of those with you today, even though we are simply highlighting Newton's laws today. Using these activities, teachers can replicate what Christa was not able to do and share from on orbit. Christa's wonderful teaching gift and spirit are captured in these videos. Her remarks and actions and training accomplish most of her lesson plans. This is a pre-flight lesson that was designed for teachers to use in the classroom to prepare their students to the live lessons from space that Christa had planned to teach. Students who experience the lost lessons will be the future that is truly touched by the gift that was Christa's. And while we've talked a lot about Christa, I will say there were 7 amazing astronauts that perished on that faithful day of January 28th in 1986. And we do still want to honor their efforts and memories. And again, tomorrow is NASA's Day of Remembrance. Within the PowerPoint, I have several different activities in there about that. There are 4 different webinars that I have on this. I'll go into them more at the end. But let's go ahead and dive into Christa's lost lessons on Newton's laws. The essential question for this activity is, do Newton's laws apply in microgravity? And if so, how does microgravity help us understand Newton's law on Earth? The objective is to demonstrate Newton's law in Earth's gravity and then compare that to microgravity. Now, we're not going to send your students up into microgravity, but we actually have videos from on board the space station by either Joe Acaba or Ricky Arnold. These activities are aligned to next generation science standards. And in looking at the forces and laws of motion, these are the 3 laws of motion as set up by Newton. So the student-led activities is designed to carry out 3 separate stations. And students will rotate through each station to test each law. You may wish to set up multiple versions of the stations so that they can work in smaller groups. But that's, you need to do what fits for your classroom. So in looking at the outline of what we're looking at today, we'll talk about the prep and setup for those 3 different stations. You'll need to copy student handouts to give your students. There is an open demonstration that they recommend you do. We'll talk about that today. And then there's actually a video on Newton's law from on board the International Space Station, and you'll have the link to that so you can share that with your students. And then as you're showing them that video, the students observe and take notes, and there's actually a handout, video notes. Then they'll go do the station activities, You'll have them do class discussions, and then there are some options for application extensions. For Station 1, you'll create a challenging path for your students to roll a tennis ball, and students use a ruler to change the direction of the tennis ball. They create the path, use 2 pair of lines of tape, and then make the path zigzag or mark the starting and ending locations. Obviously, the more narrow the path or more erratic the path, the more challenging the student activity will be. The station does require a tennis ball, a ruler, and a stopwatch, so very economical in terms of lab supplies. Station 2, you fill 2 shoeboxes halfway full of sand or flour. You may want to put paper or plastic bags under them for easy cleanup. Provide students with multiple types of balls to drop into the sand or flour, but be sure you have at least 2 of each object, so it's 2 golf balls or 2 large marbles at each station. And then you'll also use these materials briefly for your engage opening or your demonstration opening. I will say the video that you see here, not the video, the photo that you see here actually has a pan with the flour, but that flour is topped with cocoa, although that's not necessarily required for this part. But notice that I've placed that pan of flour inside of a much larger plastic tote. That's because it greatly cuts down on the mess and it helps for a much quicker cleanup. It's also transporting. You don't have to worry about accidentally dropping and spilling the entire container of flour. But that their actual activity and photo was looking at impact boxes and dealing with cocoa on top so that you could see the ejecta pattern of the impactor so much easier. Station 3, gather several different objects, balls, toys, toy cars, books, wooden blocks, and have students, if they want, gather additional materials from around the classroom on their own. Once you've prepped all 3 stations, and again, you can have multiple stations around the room that your students just rotate through, you'll want to start with an opening demonstration. And you can see the little table there where there's a verb, there's a what force the ball makes, and then what force slows the ball down. And so you pick up the ball and ask the class to think about different ways that the ball could move, such as throwing, bouncing, hitting, flicking, sliding, dropping. And as they give you those verbs, record them in that first column. And then ask the students to think about what force makes the ball move whenever you throw it or whenever you bounce it. And then also what makes it stop. For example, if you drop a ball into a box, the gravity is what makes the ball move. So gravity would be recorded in the chart. And then, of course, what slows the ball down would be whenever it hits the bottom with the flour and the sand. And so then that would be the force, the resistance force there. Ask students to consider the forces that slow the ball down. For example, as they drop the ball again into the sand and flour, they'll eventually notice that there's an upward force of that sand or flour on the ball that's slowing it. They may even notice a little air resistance that slows the ball. And explain throughout this next activity that they'll explore Newton's laws, which explain how objects and forces interact. And then students can explore Newton's laws on Earth and see how they apply on the International Space Station. And so here is the handout. It's 2 pages. There's 8 reflection questions regarding the Newton's Law videos. For me, if I were working with students, I would hand this out, have the students read the questions so that they know what they're expected to be gathering from the video. And then as the video plays, I will allow them to make notes and fill in that worksheet. Having said that, let's take a look at that video. So again, this video, and this is in partnership with the Challenger Center, shows Ricky Arnold explaining the demonstrations for Newton's laws. So let's go watch that video. And prior to getting there, I will say that the link, the YouTube link, is in the chat main. So if you have issues with this video, please feel free to click on the YouTube link and go to it.
This is Christa McAuliffe, live from the Challenger.
teachers are excited about this.
Alka-Seltzer in the container.
Look at that bubble!
Here's your reaction.
The whole country was invested in that mission. We're going to have the opportunity to kind of bring that mission full circle.
Hi there, my name is Serena Anand-Chancellor.
And I'm Ricky Arnold, and we are living and working on the International Space Station. Today we're going to look at Newton's 3 laws of motion. These laws tell us how all motion behaves under ideal circumstances. Since we are in microgravity, we may be better able to show you how these laws work compared to if you try these demonstrations back on Earth.
Let's start with Newton's first law of motion. An object in motion stays in motion, and an object at rest stays at rest until another force acts upon it. So here you can see a ball full of candy. Let's release this ball and let it float down the entire module. Normally, on Earth, this ball will eventually fall to the ground because of gravity. But up here, since we don't have gravity acting on us, or really microgravity, that ball will continue to go for a very long time.
The air in this module also generates friction, which is a force slowing the ball down very gradually. In fact, we use the friction of our atmosphere to slow our spaceships down when we land. However, if I took this ball out on a spacewalk in deep space and did the same thing, it would keep on going forever, or until eventually maybe it collided with something.
Let's look at Newton's second law of motion. It says a force is equal to the mass times the acceleration of an object. If you put the same force on 2 objects, one with a large mass and one with a small mass, which do you think will accelerate faster? Let's see what happens. You can see Ricky on one end of the module, and he's got 2 bags with him. These are bags we often use on Space Station to stow lots of items. In one bag, he has bubble wrap, very, very lightweight, well, really light mass. And as you see, as he releases that bag of bubble wrap, it really flies quickly down the module. In the second part of the demonstration, he has the same bag, but this time it is filled with water. We have a much higher mass that we're dealing with here. Even though Ricky exerts the same force on it as he did with the bubble wrap bag, you can see how much more slowly that bag of water moves down the module. And that is Newton's second law. Finally, let's look at Newton's third law of motion. This says that for every action, there is an equal and opposite reaction. If I put a force into something, it is also putting a force back onto me. Let's see what this looks like up here in microgravity when I push on 2 bags. Remember, one is filled with bubble wrap and the other with water. As you can see here, when I push the bag of water, it exerts a force equal and opposite back on me, and it looks like it's almost pushing me backwards. But when I push the bag of bubble wrap, I remain almost virtually still, just spinning ever so slightly. Can you see the difference? So as you can see, Newton's 3 laws can describe all movement. Now it's your job to see what these laws look like on Earth. Start thinking about what might be different and why. Thanks for participating in our experiment today. Signing off, I'm Serena Anand-Chancellor.
And I'm Ricky Arnold. See you next time.
So you'll notice the indications of the Challenger Center, and we'll talk a little bit about them as we go on. But yeah, all of this was done in connection with the Challenger Center. So after you watch the video and they've done the reflection with the worksheet, answer those 8 questions, there's a handout for each of the 3 stations. Now I have put all 3 handouts in this same picture. Rest assured, at the end of today's session, there's a PDF you can download and you'll have these in full page size. But you can see the 3 different sessions. So all 3 stations have engaging questions and leading questions, and then information to have them read and respond, so that through inquiry, they can compare Newton's laws and those reactions on Earth with what we have just seen on board the space station. So with Newton's law, they're going to time each other pushing the tennis ball down the paths. They can only hold the top of the ruler with their thumb and fingertips, and they can only contact the ball with the bottom 3 inches of the ruler. If the ball rolls outside the path or students use anything other than the ruler, the team has to start over. Now, what I like about this particular activity is in splitting the kids up into groups, I typically have one person that's a dedicated videographer, so that the videographer is actually documenting proof that they didn't violate any of the objectives of the activity. So that's always kind of neat. And usually the videographer is really good about making sure that they do things right. Station 2 with the second law, again, the bins with the flowers set up, drop 2 objects of different masses from the same height. Notice that they'll hit the sand and flower at the same time. And that's because acceleration due to gravity is constant. Newton's second law, F equals ma, says that the greater mass will exude a greater force. And this can be seen by the larger indent made in the flower. And if you think about looking up at the moon, you can see the craters on the moon. And what your students will actually be doing is craters in the flower. I like having the top covered with cocoa because you can see where that makes an impact so much easier, although that's not requested nor required for this activity series. I just think it's best practice. Also, like I said earlier, I actually take my pan and put it in a bigger tote just to minimize cleanup. Station 3, you're going to have the bin with the objects we mentioned earlier, and you'll have the students place the objects on the ground and take a second object. It can be, a ball, a book, whatever, and roll it towards an object that's steel, and then watch the reaction. And then have the students test out different combinations and observe the different reactions. Does rolling a ball at a wooden block have a different reaction than rolling a toy car at it? And the answer is how. And then, of course, the students answer those corresponding questions on the attached worksheets that go with each of the stations. After the students have cycled through all 3 stations, we'll come back together for class discussion and ask the students, are Newton's law different in space than what they are on Earth? If you think about the demonstrations, how do you think they would differ if they were conducted on Earth? And then why? Think about the activities you conducted in class and think about how they would be different if you conducted them on the space station. And again, why? And then ask them if they can think of their own ways, not that we've used today or in the activities that we've seen, to conduct Newton's first, second, and third law. Application extensions is to answer the following question in terms of looking at Newton's law and looking at a rocket launch. What aspects of Newton's laws are involved in a rocket launching into space? And by the way, there is an entire resource that deals with rockets and how rockets work. The link to that I'm going to put in the chat, but it's also in the notes section on the PowerPoint. Your students, there's a couple of suggestions that they might look at there as far as the first, second, and third. So you've got some ways that you can help encourage them to think about that if they don't come up with any on their own. The Challenger Center for Space Science Education is who all of these here have been worked through. Let me talk a little bit about the Challenger Centers. After the Challenger accident in January, in April of '86, the family of the crew members on board Challenger came together with a firm commitment, belief that they had to carry on the spirit of their loved ones. And by continuing on the Challenger crew's educational missions, their efforts resulted in the creation of the Challenger Center for Space Science Education. Challenger Center and its global network of Challenger Learning Centers use space-themed simulated learning and role-playing strategies to help students bring their classroom studies and life to cultivate skills needed for future success, such as problem-solving, critical thinking, communication, and teamwork. And so the Challenger Center on a yearly basis reaches over 250,000 students. They develop and deliver STEM education programs that bring STEM students to life. And in 35 years, they've reached over 5.5 million students. The core impacts is STEM career awareness, STEM engagement, STEM self-efficacy, and 21st century skill development. And so through that, the Challenger Center has been able to do that. And I want to share with you a video now on the Challenger Center that tells you a little bit about the Challenger Center. So let me show that. And I have put the YouTube link there. And while this video is playing, I will find you an updated link for rockets and how.
The crew of the Space Shuttle Challenger was dedicated to a mission inspired by education. Though these heroes were tragically lost, their mission would not be forgotten. The families of the crew created Challenger Center for Space Science Education, a way to honor their loved ones while keeping the educational mission alive.
When the kids are here, they realize that science is not something that's scary, and it's not just from a textbook, and this just reinforces the hands-on science that we do in the classroom, and the kids leave very enthusiastic and just loving science.
Challenger Center launches students into space every day, inspiring and engaging them in science, technology, engineering, and math.
This is Space Guide. We conduct a spectrum analysis of the unknown objects.
The Challenger Learning Center does indeed make learning fun. It makes me feel kind of proud about myself because I can go back to school and I can share what I learned and show it.
When the students walk through the door of any one of the global centers, they are transformed.
We are starting the landing simulation.
Astronauts, engineers, researchers, and journalists begin working together in mission control and the orbiting space station.
There could be someone in my classroom that could find a cure for cancer someday. I think it's real important for them to understand there are jobs out there that they are quite capable of doing, and some of them were real apprehensive to come in here with everything that they see around them, but to sit and be successful was absolutely fantastic to see.
No, back over.
While students share the thrill of discovery, the simulated environment brings classroom lessons to life and teaches important skills like teamwork and communication.
It would be fair to say learning is fun here because the instructors make it fun and you will have that feeling inside of you that tells you, okay, I've accomplished this, I'm glad that I listened, and you can tell yourself that I can do it.
We read you over.
It's all about innovation. To be able to spend a day being an astronaut or to work in mission control, my dream is that every child can come to the Challenger Learning Center at least once in their lives, and better still, many times.
As a leader in STEM education, Challenger Center's truly unique hands-on learning opportunities leave students with newfound excitement and passion to learn.
I do want to learn more about it. We went up in space and everyone communicated to each other.
Mission Control, we are looking forward to working with you on today's mission.
Astronauts, are you ready to go?
Great successes start with something that happened in their youth and their childhood, and this is a fantastic experience for all of my students.
Every job involves teamwork somehow to get a job done.
It's this impact and experience that inspires students to pursue careers in these important fields and command their own destinies.
The Challenger Center experience is dynamic and unparalleled to anything else offered to students.
I think the Challenger Learning Center is phenomenal, exciting, amazing, fantastic.
It was an out-of-this-world experience.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1, end of test. Roger.
That makes me just want to go to a Challenger Center now and do an activity. I will say I have done a couple, and there are Challenger Centers across the nation and literally also around the world. August of 1988, the first Challenger Center opened in Houston, and they have locations even in South Korea and Toronto, Canada, and they've even partnered with some community colleges in Pottstown, Pennsylvania, and Port Huron, Michigan, to open centers on their community college campuses. And so hopefully you'll be able to see, maybe hear centers, excuse me, near you or around you. And you say, but what if I'm not close enough? Well, if you're not close enough, they also have some virtual missions. So they have center missions, which is what we've looked at. There's also classroom adventures that you can do within your classroom, but they also have virtual missions. And virtual missions are web-based. They're developed virtually in real time with Challenger Learning Center Flight Director. They're 1 hour live online experiences. There's both pre and post mission activities. And you can find out more information about that by going to the Challenger Center website. But one of the things I want to show you, just a little clip here of one of their virtual missions on Mars. Short little clip, it's not even a minute long. And so this is a virtual option.
primary goal today is to help us identify which moon offers the best possible location for our human habitat.
And that they're actually highlighted Dorothy Metcalf Lindenberg, who is another one of the educator astronauts. There are 3. I will highlight them all in a minute, but let me wrap up about the Challenger Center. So these virtual missions to Mars, it's an option, and you can do it from wherever you're at. They also have one about the moon. We're not going to watch that right now, but you can connect with the Challenger Center. Here's their website. Also Facebook, Twitter, YouTube, several different options there that you can connect and learn more. Now, the other thing that I've done, I realize we're down to like 13 minutes left in our webinar, and I want to also give you time to download, is I have created a personal slide for each of the 7 astronauts that were on board the shuttle. And so those are there, and I'm not going to go into them, but that information will be within the PowerPoint, because to me, they deserve it. The Challenger Centers, while yes, they were created to support the families of the Challengers, but they chose to also include and highlight the Apollo 1 and also Space Shuttle Columbia. So Apollo 1 was Gus Grissom, Ed White, Roger Chaffee, and then STS 107 was Columbia. I've actually been to, there's actually a Columbia Space Center that's out in California. Then there's one there that specifically is for they don't call it it's a Columbia Challenger Center, which is really kind of cool. So just thinking about Christa, there's a couple of different quotes that I really love. Reach for it, push yourself as far as you can. And I think that's really what we want to do and strive to do with our students. And to remember that I touch the future because I teach. And even though 1986 was over 30 some years ago, Christa continues to teach and touch the future through these lost lessons. And you today as a teacher and passing this on to your students are continuing that tradition and that legacy and helping to do the same. Ultimately, Barbara Morgan, who was her backup, was selected as a mission specialist, but she did not go as a educator astronaut. She actually earned her degrees and became a mission specialist and was a first astronaut to be a former classroom teacher. So she went on and got her degrees and went in as a scientist to be a mission specialist. There is an educator astronaut program, and that was created in 1998. And then from that, we have recruited educator astronauts. The astronaut class of 2004 actually had 3 educator astronauts, and I've got a little inset of them in the upper right. Ricky Arnold in the middle, Dottie or Dorothy Metcalf to the right, and then Joe Acaba to the left. And of course, I put their names over. Joe's name is over him, Dottie's over her, and then Ricky's on his chest there. So of the astronaut class of 2004, 3 of them were actually educator astronauts, but they are legit full-blown astronauts. They went through the 2 years worth of training and earned their astronaut wings. So NASA has opened the door to professional educators to apply to the astronaut corps. Teachers from elementary, middle, and high school can apply. Ricky and Dottie and Joe represent these educators. I actually met Ricky Arnold. He was 40 years old teaching middle school whenever his application to be an astronaut was accepted. How inspiring to think that you leave a middle school classroom at 40 years of age to join NASA. But their goals are to help inspire students to consider careers in STEM and, hopefully to get those students to maybe someday join or support their space program. So the teachers in space, they spent a year of education on station. Joe was up there from September of 17 to February of 18. And then Ricky went up in March of 18 through September of 2018. So there was a focus of education on board the space station for an entire year. And as part of that, one of the things that they did out of that was the Lost Lessons of Christa McAuliffe. If you haven't signed up for NASA Express newsletter, I highly recommend you do that. It comes out once a week and it's packed full of opportunities, resources, and information directly related to educators, but also students and their families. Summer programs, opportunities to do downlinks, just lots of different opportunities. And I want to end today by showing you a video called Why Do We Explore? And as we've talked about today and highlighted the life and impact of Christa McAuliffe, truly what she talks about helps us to understand why we need to go and explore. Here's the video, and the YouTube link is in the chat if you need it.
Roger the pitch. 7, 6, 5. Roger, roger. You're looking good. 3, 2, 1.
We are the explorers. We have a need to find what is out there. It is a drive inside each and every one of us. The drive to wonder, to push the boundaries, and to explore. We expanded across our lands, settling new frontiers. We took to the oceans and learned that we could cross treacherous expanses in the pursuit of discovery. And then we took to the skies and flew. But that wasn't enough. We left the planet and redefined what was possible. We flew in space. We walked in space. What once was a melodramatic flight of fantasy became reality. Then, a new generation of spaceships captured hearts and minds for 3 decades and helped build a castle in the sky that is our lasting home in space. We have always looked up. For centuries, we wondered what was on the other side of the sky, and we have begun to answer that question. We have learned that all the exploration humankind has achieved is only a beginning. Right now, men and women are working on the next steps to go farther than we have ever gone before. New vessels will carry us, and new destinations await us. Everything we have ever accomplished leads to this moment in time, where exploration will now take us to the planets and the stars. Our nearest neighbors in the night sky have beckoned us, invited us, dared us to reach for them. We are the explorers. Throughout our history, we have taken both small steps and giant leaps in that pursuit. Our next destination awaits. We don't know what new discoveries lie ahead, but this is the very reason we must go.
I just love that. Thank you so much for your time. Thank you so much for joining us today.